So today's lesson is all about adding and subtracting polynomials. We're also going to talk about the degree of a polynomial as well as a lot of additional vocabulary. And so to start today, we have a warm-up with a system. And so what I would like you to do is go ahead and solve the system using elimination, because that actually correlates a lot to what we're doing today. So go ahead, solve the system, and come back and check your answer. And so if you look at the answer to the system, we solved by elimination. Our x's were able to cancel. 10y equaled negative 10, so we got y equals negative 1. We then took that information and plugged it into an equation in order to solve for x, where we got x equals 7. And so our final solution was the ordered pair 7, negative 1. Now today, adding and subtracting polynomials is basically this first part that you did. Here we added together two different equations, and today is very, very similar when you add polynomials together. To begin today, we have some vocabulary words. So we have the words monomial, binomial, trinomial, and polynomial. Notice these are all nomial, and nomial. And that's what we're going to be talking about today. So if we learn what a monomial is, we're going to be able to then use that information to figure out the rest of our definitions. A monomial is a term that is a product of numbers and variables with non-negative integral exponents. And so if we really analyze that definition, it says it's a term, so it is a single term that is a product of numbers and variables. So a term is usually, I think of it separated by plus or minus signs, but they can have products in them. So it could be like a 4x or a 3 or something like that. And then it says that our variables are going to be in there, which is fine, but our variables have to have non-negative integer exponents. So that means they can be numbers just like 1, 2, 3, and so on. They can't be fractions, they can't be decimals, and they have to be positive exponents on our integers. So if we look in the next row where there's these numbers and variables, these different terms, we are going to circle the ones that are classified as a monomial. So it's a term that has the product of numbers and variables, and then it has positive exponents. So this 8 is a monomial. It's a special case monomial. It's just a number, and things that are just numbers are called a constant, which you should recall that from previous years. So just numbers are monomials, and they're a special case where they're constant. Looking at our next one, 4x to the negative 2 cannot be a monomial because of that negative 2 exponent. Can't work. Our third one, 4x squared plus 3, it's a single term. It can be a product of things, but because of this plus sign in here, that's two separate terms. So it is not a monomial. And then this last example is x squared times y squared. It's the product of numbers and variables. Yes, it's a product, so it's okay so far. And our integers are non-negative integrals. Yes, so this is another monomial. And because of the variables, it's just a monomial. It is not a constant like the 8 was. Now moving forward, thinking about binomials, trinomials, and polynomials. Well, think about what it means. Bi means 2. Nomial, we know it's a term that's a product. And so a binomial is 2 terms. So a great example of a binomial would be our 4x squared plus 3. The next vocabulary, trinomial. Tri means 3 terms. 3 terms. Trinomials have 3 terms. So maybe we have a 4x squared plus a 4x minus a 4. Every time you see that plus or minus sign, it separates our terms. So we have 1 term, 2 terms, 3 terms. And then a polynomial is a monomial or sum of monomials. So typically, monomial, binomial, and trinomial are all polynomials, but typically if there's 4 or more terms, then you call that a polynomial in general versus a specific monomial, binomial, or trinomial. Now that we know the vocabulary, we have to figure out the degree of the monomial or polynomial. So to find the degree of a monomial, what you do, it is the sum of all the exponents of all the variables. So we're going to add up the exponents in all our variables. Now if we want to find the degree of a polynomial, where there's more than one just term, it is the highest degree of any term. So we have to figure out how much the sum of all the exponents, all the variables add up to, and then we have to figure out which one's the highest to find the degree of the polynomial. So looking at our first one, 8y to the 4. Well, it's one term, okay, so we have to take the sum of all the exponents of all our variables. We have just a y, so it's degree 4 because it's y to the 4th. This next one, 5mn squared, is a single term, but we have one m and two n's, so we have a degree of 3 altogether because 1 plus 2 gives us 3. 6, we know it's a monomial and we know it's called a constant. Now because there are no variables, it has a degree of 0 because there are no exponents, so there's 0 exponents. Now in the next row, go ahead and let's look at these. This first one, notice there's 1, 2, 3 different terms. So we need to figure out which term has the highest degree, and then that will be the degree of our polynomial. So looking at our first term, we have 2x's, 2y's, that has 4, the degree 4 on that term. Second term has an x squared, so we have a degree 2. And our last term's a constant, so it has a degree of 0. 4 is our greatest degree, so that's the degree of our polynomial. Next example, negative 2a to the 1, b2c3. It's a single term, so it's a monomial, so we're just going to add up our exponents. We have 1 plus 2 plus 3. That has a degree of 6. And last but not least, I want to try this last one on your own. So I'm going to pause the video, try it on your own, come back and check your answer. In this problem, we have 4 terms. The first term has a degree of 1, second term has a degree of 2, third term has a degree of 3, the last term has a degree of 0. 3 is our highest, so our degree of the polynomial is a degree 3. So our next task is to fill out this table. So we have a list of different polynomials in this first column. What we need to do is we need to identify what is our highest degree, and then we're going to classify it by 2 different ways, degree and term. The term was all our nomials that we went over, and then degree are going to be words that we've heard of before, we haven't really associated the connections. So first, 6, remember it has a degree of 0, and we said that a 6 is just called a constant. So by degree, because there is no variable, it's just a constant. However, if we classify it by term, it's one term, so it's a monomial. Now, the next one, negative 2x. There is a power of 1 on that x exponent, so our highest degree is 1. So if we were going to graph this, if you think about what it would look like on a graph, it would be a line. So if we classify by degree 1, it's a linear equation, which we've dealt with. And because it's just one term, it's still a monomial. So notice that there doesn't have to be a correlation between term and degree. It varies depending on what your polynomial looks like. Now what I would like you to do is go ahead and try to fill out the rest of this table on your own. Take a guess on classified by degree. We've talked about them before. We have linears, we have quadratics, we have cubics, and things like that. And see if you can figure it out. Come back and check your answers. So looking at the rest of the table, the third example down has a degree 1. It's a linear equation or expression, but it is a binomial. Next example has a degree 2. It's a quadratic expression and a trinomial. Next has a degree 3. It's cubic and a binomial. And the last one has a degree 4. It's quartic, and because there's 4 terms, it does not have a special name, so we call it just a polynomial. Next, we have a new vocabulary word. We have standard form. So we're going to be putting answers in standard form, and what that means, it says the terms of our polynomial are arranged so that the powers of our variable are in descending order. So that means that they're going to be decreasing, highest to lowest. And so we're going to have x4, then an x3, then an x2, then an x1, and then we could have just a number. Constants, so single standalone numbers, always go on the end. Highest degree is always going to go first. So remember, it has to be in descending or decreasing order. So if we were going to do this first one together, arrange it in standard form, there's a few things you want to think about. So you first need to look at your terms. So I see I have 2 separate terms here, and I want to make sure that my negatives stay with the right term. And so I always like to think of this as a plus minus x. So 4 plus a negative x, because I know my x has to go first. But it's not just an x, it's a negative x, and that's a positive 4, so it's plus 4. So this first example in standard form is negative x plus 4. Same with the next example. I like to think of them as plus negatives instead of minus signs. Highest power goes first, so I see I have an x cubed, so 7x cubed stays first. My next highest power is at plus x squared. Next will come my negative x, or minus x. And last but not least is my negative 2. Same with this last one. Negative 4x to the 5th goes first. Then my negative 3x squared, then my standalone positive x, and last but not least my number plus 11 tacked on the end. Next, in order to add and subtract polynomials, we have to think about combining our like terms. So, what are like terms? Like terms have the same variable with the same power. We've done this before, it's just a refresher. Same variable with the same power. So, to get your mind in the right spot, match the terms on the left with their like terms on the right. Go ahead and do that, come back and check your answers. Like terms have to have the same variables with the same power, remember that. Next, we want to simplify by adding together our like terms. So my like terms, I see a g to the 2 and another g to the 2. Here's 3 of them. Here we have 1 of them. Altogether we have 4 g to the 2's. Notice, the variable and power do not change. Next I see I have a 2g, but nothing else goes with it, so I just have my 2g. And same, I have that 1. And last